If you want to have a platform that has some type of shared storage or shared compute, some type of power consumption or resource consumption, long term, you're going to have somebody to pay that, and that's going to have to be a sustainable model.
Welcome to Hedera Hashgraph's Gossip About Gossip. I'm Daniel Francis.
I'm Ken Anderson.
And I'm Paul Madsen.
If you are a developer, an entrepreneur, crypto enthusiast, or just trying to learn more about how distributed ledger technology and Hedera Hashgraph will impact your industry, then you'll love the episodes that we have coming up. Bookmark us, add us to your podcast app, and stay tuned.
Hey there, and welcome to Hedera Hashgraph, Gossip About Gossip. I'm Paul Madsen. I'm joined today by my Hedera colleague, Ken Anderson. Hey, Ken.
Hey, Paul. Glad to be back.
Yeah. So we want to talk today about rent, all things rent on Hedera, why we need it, why other public ledgers seem to be recognizing that they need it, even if they didn't build it in from the start, and how it looks. So maybe let's start by defining rent. How would you define it?
I think it's a necessary property of any distributed ledger. The reason why I say that is that nothing in life is free. Someone has to pay for storage and compute. And I think it's admirable, and I think there was some good intent in maybe funding a lot of that storage and compute power with initial investment funds in some previous projects. But even some of the other projects are coming to realize that that's not sustainable. If you want to have a platform that has some type of shared storage or shared compute, some type of power consumption or resource consumption, long term, you're going to have somebody to pay that, and that's going to have to be a sustainable model. So I think we're seeing with even one of the biggest projects out there, they're right now trying to figure out how to solve this problem of rent because the blockchain size is getting so big, it's not sustainable if they don't cover that. And I think in our case, Lehman's been very clear from the beginning that everything that happens on Hedera, we're going to charge for. And we're doing that with our eyes wide open. We're doing it completely transparent and honest with the community. We want everybody to understand, like, this thing is going to cost resources. It's going to take resources, and we have to have a sustainable model that lasts long into the future, not something that's just short term and is going to have to get patched.
Well, to your point, other ledgers have charged for, quote unquote, what happens on the ledger, charged for compute, charged to some extent for storage. What those previous models haven't done is accounted for the duration of that effort, right? The duration of the storage. They haven't had a temporal aspect to determining what pricing is. And that's what I would characterize as the sort of the fundamental criteria for rent, right? That not only do you count how much work you're doing, but you count how long you're doing it. That's rent. And that's distinct from buying a permanent space in a block, as in some other models.
Yeah, I think that's an important distinction too, because the concept of rent is that there's some interval that you have to renew that rent. You have to pay that rent to continue utilizing that resource. So I think the duration is an important distinction. In blockchain, kind of the fundamental models that you have to keep all of that history back to the Genesis block. So every time something happens on a blockchain, you create an additional burden on the future. And the question is, okay, who's going to pay for that future storage burden and even compute burden if you have to validate the blockchain back to the Genesis block? So who's going to carry that burden? And I think that's a fundamental difference with, the Hashgraph algorithm. We vote in rounds, and we get that 100% finality within seconds. And then once we have the finality of that vote, it's completely up to us whether or not we want to store the history or not, because the voting's done in rounds. And at the end of a round, it's final. And those rounds are very quick. So if we decide that we want to store things longer, I think for us, it was more apparent that, yes, you're going to have to pay for rent, just like you would with Dropbox or Amazon AWS S3. You have to pay for that storage because that's an additional burden. And I guess part of it is also, when you start getting really high throughput of transactions, it doesn't take very long for that burden to get excessive if someone's not paying for it. I should say if it's not a sustainable model, that gets excessive. And so, yeah, I agree 100%. So the concept of rent is that there's going to be a periodic payment or renewal to maintain the storage or whatever the resource is. So there's a duration component to it. And then also just the nature of Hashgraph means that it's kind of an optional thing. So it's not just thrown onto the entire community to maintain it. It now becomes a thing of where the individual users of Hedera can choose to or not choose to extend something for some duration.
Right. And when we talk about rent in a Hedera context, we're talking about storing in the consensus state. Because as you say, we don't automatically have that default burden of storing transaction history. We're talking about the burden that nodes take on for storing some amount of bytes for some period of time, and how we fund that, bottom line. Who pays that, when they pay it, how often they pay it, and how we ensure that the nodes ultimately get that payment.
Yeah, that's right. So, and I think this is going to take a bit of a shift, a paradigm shift for dApp developers. But I think it's a necessary one that's going to happen across every platform. And I only say that because there's a sustainability component. In any scenario where you don't have this proportional distribution of burden amongst the users, and there's some presumption of permanence, even though there's no income or compensation to be applied to that additional storage, that's not really a sustainable model. So it needs to be something that is scalable and sustainable. And that's really what we're looking at here. And I think every other platform is starting to either see it now and have to start adjusting. We've heard the word rent a few times in some of our other distributed ledger platforms. And I think some other newer ones are already taking this into consideration. So I think it's an important component that's going to happen. There's going to be a paradigm shift for dApp developers because up until now, dApp developers haven't had to put too much thought into what does a business model look like where that burden is shared with the users of the dApp. And this maybe comes back to thinking about, okay, we're going to have this permanence. If I'm building a mobile app and I have a back end that is hosted on Google Cloud Compute or on AWS, I, as the mobile app developer, am responsible for paying that monthly fee to keep that storage and compute, that API up and running for my mobile app users. I better well have thought through, how do I monetize the app sufficiently to cover those costs at the very minimum? And I think we're just going to get that same mentality moving over into the distributed ledger space. I mean, we're going to have to take that model that has been around for quite a while, by the way. That's not a new model. It's actually a relatively new model not to have to think about that, thanks to DLTs, because the idea was that if you were a node in the distributed ledger, you were sharing that burden with everybody through your storage, but not all dApp developers are also node hosts. And I think that's one of the big differentiators.
So right, in this future architecture that's emerging, the dApp may well continue to use AWS and have to fund those costs. But if they're using a DLT like Hedera for the trusted timestamps or provenance and storing hashes of information actually stored on AWS, they have to think about those costs as well. And it's that hybrid reality, and the economics have to cover both. Okay, so we've been talking about rent at sort of a high level. One particular use case that rent is going to manifest or have a significant impact on potentially are smart contracts. What do you think there?
Yeah, that's one that's kind of got my attention right now. And what I'm doing, as a developer advocate, I have to advocate for developers. So I'm walking through these use cases and I'm trying to figure out, what does this look like from a business perspective and kind of a holistic use case perspective? It's going to require some business thought here. We're going to have to think through what the economics look like and who's going to shoulder which burden. But there are a few different models that come out of it. I mean, if you think about the fundamental model, which is I'm going to store a smart contract to the file system because that's how Hedera works. And then I'm going to instantiate that smart contract on the smart contract, the Solidity VM. And then there's going to be a renewal period for both the file that's being stored and the instance of that smart contract. And that renewal period is going to come up at some point in the future. And the question is, let's look at a use case specifically. If I've just got a simple, fungible token, very lightweight smart contract, I store it onto Hedera and I say that this is going to renew every year. If I were just to take a very simple smart contract, an ERC20 smart contract, and store that, the question now comes up, if this token gets really popular and all of these records get added to the in-memory ledger, that table that holds the balances for every token holder, that could become a very large state. And at renewal time, if I set my renewal period for 1 year, who's responsible for renewing that token? Who's got that burden? Is that the admin that's supposed to do that? Because if I, as an admin, publish the smart contract for, say, a dollar or a couple dollars, and then at the end of the year find out that there's $15,000 worth of state, am I supposed to be responsible for renewing that? How do we handle that?
You're making a distinction between the size of the bytecode that was initially stored by the contract admin and necessarily funded. The storage was funded for a year or whatever the chosen time period was. And distinct from that, in addition to that, is whatever growth in the table that you referenced, ultimately a metric of how successful the smart contract is. The bytecode is going to stay the same, and that storage burden stays the same, but growth in the state associated with that contract is unpredictable to some extent.
That's right. And, while people are transacting, so trading and buying the token, they're going to pay for the storage of that state from the time that they bought until that renewal period that the admin defined. So whoever created that smart contract has that renewal interval defined. And if that's 1 year and I buy it 6 months, I have to pay for 6 months worth of state of holding that table entry for my balance. So to your point, you've got the bytecode, which is going to be relatively consistent, right? Bytecode's not going to change when I deploy a smart contract. And I know what that renewal is going to look like, and I can fund that for a very long period of time, and I can predict that as a developer. The state is what I'm thinking about. So the state being, for every new holder of that token, I've got an extra record in my table with a balance next to it. So I've got some identifier and a balance and maybe some extra metadata about that particular record. So I've got the state that's going to grow with the more holders that I have. And the question comes in, okay, the holders are shouldering that initial burden, right? So that until that first renewal period, they're going to pay for that additional state. But at the renewal period, who pays for the additional state for the following year? And so that's really the question, because, if you don't cover that state cost and there's insufficient funds in the contract itself to renew it, then the contract could disappear. Now, this is pretty consistent with, what you do in the traditional sense. So with AWS and with Google Compute, if you're going to store anything of value on Dropbox, you expect that Dropbox's business model is charging me as the end user enough or monetizing the data sufficient to cover the cost of my storage, and my storage isn't going to disappear. So I think that's where we're going to have to shift a lot of the thinking, because in previous distributed ledgers, you haven't really had to think about that, specifically in blockchain, because they think of it as a shared burden in the storage space. But that's changing because this burden is getting very big, and we got to be able to compensate the nodes for that. So this is what I'm saying is now we got to come back to this model of, okay, how do we do that? And I think there are a few models. So one model that kind of brute force came to mind for me was, well, if I'm the admin and I want to have something that's predictable and I want to take on the burden myself, then maybe what I say is, well, I know that this smart contract is going to be in existence for some period of time, we'll say 10 years. And I want to cap the number of token holders or records in my table to, say, 10,000 records. And so I know I can calculate what my max burden is going to be at each renewal. That may not be completely accurate because it could be smaller than what I calculate. But if in my code, in my smart contract, I say I'm only going to allow 10,000 holders of my token, then I can at least cap the max. And I can pre-fund the smart contract for, say, 10 years at a 1-year renewal interval. And every year I can reevaluate the costs and figure out, maybe I have the ability to change the total number of holders at that time. Whatever the case may be, or maybe I do it monthly, but at least that's predictable. At least that's something that I as an admin can control. And when people buy my token, they can have confidence that this token is going to exist for the period of time that this business exists. So if it's a real estate investment opportunity, maybe 10 years or 20 years is the period that we're engaging on these contracts. And we're going to pre-fund this token and we're going to cap out the number of token holders so that I know exactly how big my state is going to be. And that's going to give people confidence. They're going to see that in the code. They're going to see that in the balance. They're going to see that in the state. and people will feel confident investing in it because it's pre-funded and there for good for the period of that business engagement.
And maybe that model makes sense where there's value in exclusivity, right? We know it's 100 token holders at max or 1,000. And so it's both predictable and valuable to restrict the total. Okay. What are some other models?
So the alternative to that model is that I, as an admin, know that this business engagement is going to last for 10 years or 20 years or whatever it is. Because realistically, there are parameters, there are realistic durations to contractual agreements. So suppose we have a token that is not going to live forever. We know that there's a period of opportunity or engagement, say like a real estate investment or other types of securities. And we know that this is going to be good for 5 years or 10 years or 20 years or whatever the case may be. What I can do is I can set my renewal period to whatever that expected business opportunity period is. Now, what this does is this means that anybody who buys a token, remember how earlier I said that as a token holder, when I buy a token or I transfer a token, anytime there's that new account created, I'm going to pay for the additional state from the time that I buy it until the end of that renewal period. So if we make that renewal period 10 years, for example, then I, as the admin, just deploy my bytecode, and that's going to be relatively cheap. And then anybody who buys the token, in other words, anybody who adds a record to my state, is going to pay for that additional record from the time that they bought until the end of that renewal period, which will also be relatively cheap because it's just one record's worth of information. And this kind of allows me to say, okay, I have no cap on the number of holders, but I do have a lifetime for this token. But this allows it to scale. And then at the end of the lifetime of that token, we can make a decision of, do we convert to another token that does the same thing? Is the business opportunity, finished? Are we done? Whatever the case may be, there's a way for that to work. In the first case, I'm saying we know that we have a fixed period of engagement and a cap on the number of users, and I pre-fund it as the admin. In the second model, we're saying, well, we don't have a cap on number of users. We do have a fixed period of business opportunity or business value, and I don't have to pre-fund it, and the users kind of fund it along the way. And I think there are some other distributed ledgers that are kind of following that model to a degree, where they're saying, I, as the admin of the smart contract, have a specific burden for the fundamental code, but the users have the burden for the storage or for the execution of that code. And I think that's a much more scalable model. And in that case, even the smart contract admin or the developer doesn't have to have some big onboarding costs. They can just go with the minimum bytecode deployment.
So in the first model, you minimize the sort of risk at renewal by capping the number of records. In the second model, you minimize that risk by potentially not renewing, right? That the contract has an explicit lifetime and expires afterwards. So the third model, one where you don't limit duration, where you do allow for continuous existence of that contract and arbitrary numbers of users, would probably be the most general. How do we handle that?
That would definitely be the third one, because we're basically saying the first one we're capping users and capping duration. And the second one, we're only capping duration. And we're also spreading the burden of the cost. So now it's much more sustainable. The third one is, okay, how do we make this in perpetuity? How do we make this go on forever so we have no duration cap and we have no user cap? So I would say that it's partially that second model where users are responsible for buying their tokens, but maybe at the end of that contract period, there's a pruning operation that the admin triggers, or that could even be automatically triggered. And users have to basically renew their individual record. And this could be programmed into the smart contract. So the individual record has to pay fund renewal. Now, obviously, this is going to add another field to the actual record itself. But in this model, you basically say, listen, every 2 years or every 1 year, this token renews. And if you as a token holder renew your record for the following year, or you even pre-fund it for X number of years, then your token will remain in existence. And I think that's probably the most sustainable model, but it does require that there's some mechanism for that renewal period. There has to be some way for end users and token holders to know that there's time to renew and that they are able to renew and that their wallet supports that renewal mechanism. But I think that's probably the most fair and definitely the most sustainable of the models.
Right, where individuals pay for their own records, their own tokens, does suggest a usability burden of managing the duration and renewal of multiple tokens, potentially across multiple DLTs.
Yeah, that's right. And I don't think it's a foreign concept. I mean, we do it anytime we park a car in a public parking space. We pay for a period of time, and if we leave our car there longer than we said, we pay more. And if we don't pay within a certain period, they tow our car. So we deal with this in parking as well, but that's kind of what we're doing is we're parking our tokens. When we buy the token, we have token ownership, but you can think of it as whatever that token represents, whatever rights that token represents are being parked in this ledger, and you have to just maintain your parking. You have to pay your fees, or the token disappears at some point, gets towed.
He gets towed, yes. Ken, awesome. It was great talking rent with you.
Yeah, I'm sure rent has a very positive connotation with everyone. But I think this is an important conversation, and it's one that the DLT space in general is going to have, and some ledgers are having this conversation, and it's one that kind of is fundamental and core to Hedera, and we're already there. And I think it just makes sense. And I think right now the trick is, how do we get the mind share? How do we get people to understand this and build this into their dApp development? And that's part of why we're having this conversation, is we want that to be an open and clear. And we've always been very honest and open about this idea of paying for resources. That's been one of the fundamental tenets of Hedera, which is sustainability. And this is part of that.
Yep. Again, Ken, thanks a lot. Let's do this again.
Will do. Take care.
Thank you for listening to Hedera Hashgraph's Gossip About Gossip. If you liked the episode, please subscribe, rate and review, and also share and tell your friends.
Or connect with us on social media like Twitter, Instagram, etc. at Hashgraph, particularly if you want to leave us feedback on the podcast. We look forward to hearing from you.